Yeah, hello everyone. I'm gonna show you how to use TopSpin NMR for NMR analysis. And first of all, what we should have is having feed file. So normally, after you run NMR using through the instrument, you will have raw file which is for further analysis in the TopSpin NMR software. And after having this feed file, for example, this is for HNMR, this is for carbon decoupled HNMR, and this is fluorine NMR. But I want to show you how to use HNMR now first. And uh, so this already connected to the broker TopSpin. So we would like to see which one. 15H. So what is 15H? This is the code of my sample 15H YPB 15H. So let's start to use this software. So 15H, and I'm gonna show you how to use the HNMR first. So basically we'll delete this first. Let's start from the beginning. So after having this spectrum, firstly what you should do is calibrate the theoretic solvent peak first. So in this spectrum I use chloroform CDCl3. So I should first calibrate this. And what is the chemical shape for CDCl3? So we can see here from this paper, we should see the chemical shape of CDCl3 chloroform, which is 7.26. So then we should calibrate the peak to 7.26. Okay, already 7.26. So basically you do like this and click OK, and then it will be shifted to the correct chemical shift. And then of course from this molecule what we should have is 2 hydrogen over this and 2 hydrogen over this. So it's kind of double multiplied, something like that. Or doublet. So but what I found here is, so first of all, then we can use this first to pick a peaks of each. So use this. Okay, let's start from the beginning again. So we should choose this, and 7.26 already, and we zoom in over here, and already picked. And then for this one, let's pick the peaks, and for example like this. Then return and save the change, and double click again, or you can use this for zoom out or zoom in. And the next step, what we should do is integration. So we use this from process, click process, and we use integrate, and click over here, and let's try to define the integration of these peaks and this one. So 1 to 1. Then we double right click, or I use Mac, so I use right click over here and carry blade 2. So here 2 and 2, it means this 2 and this 2 also. Then save, and then the next step is we should analyze. So the multiplet, click zoom in over here. Okay, first of all, click this one, sorry, this. So what we see here is kind of doublet, or we can say here is doublet 7.5679 with J coupling is A. So we can write here 7.57, and then click, then you have to write the detail. So the J coupling J H H so from here 1 2 3, so it should be 3 H the resonance. We should write the resonance of the J coupling, so it's A. This is A equals A hertz. Then it's supposed to be 2 hydrogen, and okay, from here we should doublet. We click here doublet, right here doublet 2H, and where is it? This is H, and so this is the standard for kind of wiry journal, so we should write like this at least, and we should start from the biggest one. So, and here, what is it? It's supposed to be double multiplied. So if you click over here and pick number 2 and 3, 2, 3. So then we can ignore the decoupling of the list over here from the bottom, and we just have to pick the decoupling from the first line over here, or the L2. So it's, so the shift is 7.77. We can write from here 7.77 double multiplet and what is it? It's supposed to be 3JHH. It's supposed to be common 9 hertz, 9 hertz, 2H, H, or we can write like this. Then we got the data of this NMR, the analysis data already done. And the latest step, what we should do is click this plot, and we can remove this part. We can remove this. We can add later. And can add the curve or not, so I prefer to remove the curve. And we should change the green one here, the color, to the black one, so it's much more easy to recognize. And we can start here from axis from 0. Okay, or here we can say 14. Okay, then we can click copy and paste. Okay, for this one we can remove the label, or we can add the label still, and we decrease the scale. You can say here is 27, and this one 8, so we make it small again, and this is 7.5, 7.8. See, okay, this is enough. Then we can click copy and see, paste to this side. Okay, then it's done. So for the NMR, this is done. So what I can show you here on the proton NMR. So if you have some question, you can write to the comment below, and I hope I can reply as much as I can. See you.